Good evening, boys and girls. Welcome to another lesson on Technical Sciences Grade 12. It's the 21st of September and it's a Monday and it's a really good start to the week. And we are continuing with organic chemistry. Remember, I told you that organic chemistry counts a lot of marks in paper 2. So in the previous week, we dealt with we dealt with nomenclature of organic compounds. And this time around, we are going to look at organic reactions. Remember, we still have another section that we will look into, and that is physical properties of organic compounds. So at the moment, we are going to look at organic reactions. So I hope you have your pen and paper ready and you are ready to begin your lesson with me. Right. So in the overview of our lesson today, we'll just look at what exactly are we required to know in terms of organic reactions as per our examination guidelines. Then in the features of the topic, basically we will be looking at reactions and for enhancing our knowledge and so on, we will be looking at various definitions of what each reaction means and so on that we need to learn. So it's specific terms and they will mean something in terms of organic reactions, and therefore we have to learn those. And I will also give you tips in terms of how many marks you can expect this section on organic reactions to be for your preparatory examinations, especially for those that have not as yet written that one. Right. So if you go directly into your examination guidelines, under reactions of organic compounds, you will see that we are supposed to know oxidation reaction, what we also refer to as combustion reaction. So we will be able to write down an equation for the combustion of hydrocarbons in excess oxygen. So we'll be looking at how hydrocarbons actually react in the presence of excess oxygen gas. So we'll be looking at what are the requirements for the reactants and what are the products that are formed when an organic compound, or rather a hydrocarbon, undergoes oxidation, or what we then refer to as combustion. Then we will look at substitution as well as addition reactions. So firstly, we must be able to identify a reaction as either a substitution reaction or as an addition reaction. Furthermore, we must be able to write down, using structural formulae, equations, as well as reaction conditions for the following types of addition reactions. So basically here, we are basically trying to say, using various structural formulae, we must be able to write down a fully balanced equation for a chemical reaction that takes place, especially for our addition reactions, when molecules from the homologous series alkenes react. So we will be looking at addition reactions of alkenes, and in particular we'll look at different types of addition reactions. We are going to look at hydrohalogenation, we will look at halogenation, we will look at hydration, we will look at hydrogenation, and all those four are examples of the type of addition reactions that molecules from the homologous series alkenes can actually undergo. And when we look at hydrohalogenation, basically we are looking at the addition of a hydrogen halide to an alkene. Now it will get easier as we do the actual reactions, but putting simply, it is to say we will be looking at what happens when you add a hydrogen as well as a halogen at the same time to an alkene molecule. Then we are going to look at halogenation, and that is when an alkene reacts with a halogen. So we'll only look at bromine as well as chlorine with a compound, and that is a compound which is an alkene. And then we will be looking at hydration as well, which is the addition of water to a compound. So what happens when you add water to an alkene? And in terms of addition, the last type of addition that we'll look at is hydrogenation, which is the addition of hydrogen atoms to an alkene. So there we will be using hydrogen gas. Right. Furthermore, we must be able to write down, using structural formulae, equations and reaction conditions for the following substitution reactions. So we will look at hydrolysis of haloalkanes, and that is when your haloalkanes are basically reacting with water, and your substitution reaction will take place in that regard. Then we will be looking at hydrolysis basically in general, which is the reaction of a compound with water. And then we will be looking at reactions of haloalkanes with alcohols as well to produce various haloalkanes and various alcohols in that regard. And we will be looking at halogenation of alkanes, and that is an example also of a substitution reaction whereby a halogen reacts with an organic molecule from the homologous series alkanes. So that is essentially what we are supposed to know. But for today, we are just going to look at oxidation reactions, which is your combustion reactions of various hydrocarbons, and we are just going to look at addition reactions of alkenes. So that is essentially the focus of the lesson for today. Right. Let us go further now and investigate the first type of reaction, which is combustion. And we are going to look at what happens to alkanes when you react them in the presence of oxygen gas. For example, let us take a molecule like propane and react it in the presence of oxygen gas. So if you take a molecule like propane and you react it in the presence of oxygen gas, you are going to form your product as carbon dioxide and water. Now, how do we write down this particular reaction? Firstly, we are going to use molecular formulae to represent your propane. Now, when you write down the molecular formula of propane, you will then know that you actually have to look at propane and count the number of each type of atom that exists on propane. And we understand that propane belongs to the homologous series alkanes. And if it belongs to alkanes, it is a hydrocarbon. And by prop, we know that we must have 3 carbons. And that is essentially what we have learned. So it will have 3 carbons. And when you look at the hydrogens, you then know that propane has 8 hydrogens. So the molecular formula of propane is then C3H8. And then, because it is undergoing combustion, it means your propane is reacting in the presence of oxygen gas. So your oxygen gas, you have to write it as O2. You cannot write it as O. And those are some of the mistakes that we really come across as we mark you. Remember, it is burning in the presence of oxygen gas. Then what you have written on the left are actually what we refer to as your reactants. So these are actually your reactants altogether. So those are the things, or those are the molecules that are reacting. So these on the left hand side are your reactants. And then when propane undergoes combustion, then there are products that are formed, and the products are written on the right hand side of the arrow. And we can see that your products are definitely carbon dioxide as well as water. So the molecular formula of carbon dioxide is definitely CO2, and the molecular formula of water, it's definitely H2O. So these are the products that you form. So how are we going to allocate marks here? The first mark is definitely for the reactants being correct. The next mark is definitely for the products being correct. Then the last mark is for you to balance this chemical equation. Remember, to balance this chemical equation means the number of carbons on the left must be equal to the number of carbons on the right. The number of hydrogens on the left must be equal to the number of hydrogens on the right. The number of oxygens on the left must be equal to the number of oxygens on the right. Now, to make the balancing of this molecule easy for yourself, firstly, go and balance the number of carbons. In other words, make sure that the number of carbons on the left is equal to the number of carbons on the right. After you balance the carbons, then you go and you balance the hydrogens. So it means you are going to make the number of hydrogens on the left to be equal to the number of hydrogens on the right. And then you are going to look at your oxygen molecules, and that will be the last one. So the number of oxygens on the left must then be equal to the number of oxygens on the right. So what is the sequence here that is best to use for balancing? It is first to balance the carbons, and then to balance the hydrogens, and lastly to balance the oxygens. Now remember, when we balance the mole ratios. In other words, we balance using the numbers that come before the actual reactant, and balance using a number that will then be put before your products. In other words, you cannot balance using any number there. You can't balance there altogether, because now when you balance there, you are actually changing the product. It means the product will no longer be carbon dioxide. Now, let's see exactly what I am trying to say to you. Now, let us check how we balance there. So we are first going to check how many carbons do we have on the left. Then I can see it's a C3, so it means I have 3 carbons on the left hand side. Then I go and I check the right hand side. I can see that it's C. There I actually have an invisible one, so I actually have 1 carbon on the right. So the number of carbons on the left is actually greater than the number of carbons on the right. So I need to balance the number of carbons that are on the right-hand side. Now, what if I was tempted to put a 3 there? Now, we definitely know that by doing that, it is incorrect. Why? Because by balancing there, then this molecule is no longer carbon dioxide. So this is definitely incorrect. So where do we balance? In other words, because that is incorrect, I'm just going to erase it there for you. We balance with the numbers that we get before the reactants and the numbers just before the product. And scientifically, we call those mole ratios, or what we call stoichiometric coefficient. Then I see that, oh, then I must balance there with a 3. Now the number of carbons on the left, it's actually equal to the number of carbons on the right. Then I look at my hydrogens. I can see that on the left-hand side, I actually have 8 hydrogens, which is an H8, but on the right-hand side, I actually have 2 hydrogens. So to make sure that the number of hydrogens are equal on the left and the right, then I have to balance the number of hydrogens that are on the right-hand side. So to make this an 8, I'm going to balance there with a 4. Why do I balance with a 4? Because if I say 4 multiplied by that 2 there, it is going to give me 8. So the number of hydrogens on the left, it then remains as 8, and the number of hydrogens on the right, it is also 8. Then I check my oxygens. The number of oxygens on the left, it's 2. And the number of oxygens on the right, you can see that it will now be 3 multiplied by 2, which is going to make it a 6. And again, I have oxygens there, so it will be 4 multiplied by 1. Remember, there I have an invisible 1. So 4 multiplied by 1, it's 4. So this will be 6 plus 4. So when we actually count, we can see that the number of oxygens on the right gives me 10. Can you see what makes it different? Now I actually have to balance now on the left-hand side. So to make this 10, then I have to put there a 5. So if I put a 5, then I know that 5 multiplied by 2 is going to give me a 10. Then I go back and I double check. Number of carbons on the left, it's 3. Number of carbons on the right, it's 3 as well. Number of hydrogens on the left, it's 8. Number of hydrogens on the right, it's 4 times 2. It also gives me 8. Number of oxygens on the left, it's 5 times 2. It gives me 10. The number of oxygens on the right, it's 3 times 2. It gives me 6. And it's 4 times 2. Rather, it's 4 times 1 there, because the oxygen is a 1. Then it gives me 4. Then 6 plus 4 gives me 10. Then I'm going to get a third mark for what? For balancing altogether. Yes, because the number of each type of atom in that reaction on the left must be equal to the same type of atom that is on the right-hand side. So this balanced chemical equation is going to give you 3 marks. And we can definitely conclude that it is a combustion reaction because propane is burning in the presence of oxygen gas. If you don't call it combustion, you can also call it oxidation. Now, you see, I want to give you a tip there. When you look at this particular propane, you can see that it has 3 carbons. So this is an odd number of carbons. So it becomes easy for you to balance it. But let us look at the next one. When you look at this molecule with 4 carbons and 10 hydrogens, the second one, you can definitely conclude and say, Menier, this one is butane. So it means butane is reacting in the presence of oxygen gas. So you can definitely say to me that, Menier, when I look at this molecule, butane burning in the presence of oxygen gas, and my products being carbon dioxide and water, if I asked you for the type of reaction, you would have said to me the type of reaction here is combustion. Why is it combustion? because butane is burning in the presence of oxygen gas. So you will get 1 mark for your reactant, you will get 1 mark for your product, and the last mark must be for balancing. Now, I just want to show you something here. You see, when you look at this molecule and you can see that it gives you an even number of carbons. And I don't want to go into a lot of steps with you that might end up keeping you confused or getting you confused rather. So the first thing that you do, you will remember I said we balance the carbons first, and then we balance the hydrogens, and then we balance the oxygens. So the first thing that you can do for yourself there is to actually just put a 2. Now, when you have put a 2 there, then you just balance the rest. And the reason you start by balancing with the 2 next to the carbon, next to the butane, is because you actually have an even number of carbon atoms. Because when you have an even number of carbon atoms, it does not balance straight away like this one, where we had an odd number of carbons. When you have an odd number of carbons, you don't put anything there. But when you have an even number of carbons, just put a 2 in front. And when you have done putting a 2, then the rest is very easy. You just check. How many carbons do you have on the left? You will say it's 2 multiplied by 4, it's 8. Then on the right, I have 1. So it means to balance, I need to put an 8 there, so that the number of carbons on the left is equal to the number of carbons on the right. Then for hydrogens, I have 2 multiplied by 10, so it gives me 20. On the right-hand side, I have 2. So I need to balance on the right-hand side and make it a 20 as well. And to make it a 20, I'm going to balance there with a 10. Then I'm going to look at my oxygen molecules. On the left-hand side, I have 2 oxygen molecules. On the right-hand side, I have 8 multiplied by 2, which gives me 16. And then I have 10 multiplied by 1, which gives me 10. So it will be 16 oxygens plus 10 oxygens. So in total, I have 26 oxygens on the right-hand side. So if I have 26 oxygens on the right-hand side, then I have 2 on the left-hand side. It means I need to balance the left-hand side. And to make the left-hand side a 26, then I'm going to balance there with a 13, because 13 multiplied by 2 gives me 26 altogether. Then I am going to get a 3rd mark for balancing. So it is critical, my dear learners, that you ensure you are able to balance this chemical equation. You are able to use these molecular formulae, right? Your C3H8, your C4H10, and all of those to write down a balanced chemical equation. And you must also be able to identify this particular reaction as a combustion reaction or as an oxidation reaction, because your alkane molecules were burning in the presence of oxygen gas. Right. Then let us move to another type of reaction that alkanes can undergo. Now, when you look at this type of reaction, the first thing that you must be able to see is that this is an alkane that is reacting. And we can see that the molecule that we are looking there, it is ethane. And I trust that by now you know why this molecule is ethane. We are not really looking at nomenclature. We have treated that last week. So we have ethane, and it is burning, or rather it is reacting with chlorine gas. Now, if I ask you what type of a reaction will take place here, you will definitely tell me that, Menier, this cannot be substitution, rather this cannot be oxidation. Why can it not be oxidation? Because it's not burning in the presence of oxygen gas. But I can see that this ethane, this alkane, is reacting with chlorine gas. So the possible type of reaction that can take place here is for one chlorine atom to actually substitute one hydrogen atom. So in essence, what we are saying is that one molecule of chlorine can actually react, rather one atom of chlorine from this molecule can react with the ethane, and it can bond with the carbon there, and the hydrogen will be removed. So when we do that, what are we going to form? Then we know that on the left-hand side, we have our reactants. So what we have on the right-hand side of the arrow are then our products. Now, when we look at our products and compare it to the reactant, can you see that in the reactant there, I had a hydrogen atom. But what I have formed does not have a hydrogen atom anymore. It has a chlorine atom. In other words, this hydrogen that was there has now been substituted by a chlorine atom. Remember, when you substitute, you remove one atom, and after removing that atom, you place a different atom there. You can't place the same atom. You place a different atom there. So you can see that I have removed the hydrogen there, and I have substituted it with chlorine. And that is why we say the type of reaction that is taking place here is definitely substitution. Now, to make sure that again our equation is balanced, remember what is going to be left now. It will be this one chlorine that did not substitute into the alkane, and the hydrogen that I have removed. So what does that give me? It gives me that this other product that is going to form will be between this hydrogen that I have removed and that Cl that did not substitute into the alkane. And then my other product is going to be HCl. And this product, we can see that this is an inorganic product. We classify this product as a product that is inorganic altogether. Why are we saying this molecule is inorganic? Because I can see that it is made up of chlorine and hydrogen. So there is no carbon. So if there is no carbon, the molecule is not organic, and instead we say it is inorganic. So this is the inorganic product that is formed, and that is another question that we can ask you, to write down the molecular formula of the inorganic product that is formed. Again, what you should also see is that this is a reactant. So this reactant also does not have carbon. So we classify it as an inorganic reactant. But this one, which is ethane, we classify it as an organic reactant because this molecule is organic. And this molecule as well, it belongs to the homologous series haloalkanes. So it is an organic molecule. And because it is an organic molecule, then we classify that as well as an organic product. Now, you see, when you look at alkanes, alkanes have single bonds between carbon and carbon atoms. Now, this single bond between carbon and carbon atoms is very stable. And because it's very stable, it actually makes alkanes not to react easily. But as scientists, we can't say because alkanes do not react easily and we don't do anything about it. So we try to make them to react. And if we want them to react, we make sure that the reaction conditions that we meet are that we provide heat and that the reaction occurs under a high pressure. So these are the conditions that we are supposed to meet. It means if these two conditions are not met, then this alkane is not going to react because it does not react easily, because this single bond between carbon and carbon atoms is actually stable. As a result, to ensure that your alkanes react, let us make sure that we provide them with heat as well as high pressure. Now, if you do not have any form of heat that you can provide and so on, the best thing to subject your alkane to is to ensure that you perform that reaction where there is sunlight altogether. And basically, when you talk about sunlight, you know that we will still be getting that UV radiation from sunlight. So when you list the conditions, you will then say to us, it's heat and high pressure, or you could say it's sunlight and high pressure, or you could say it's UV and high pressure. It means you cannot give me two conditions as heat and sunlight. You can't, because heat and sunlight, they serve the same purpose, but heat and pressure, they do not serve the same purpose. Right. Now, what questions can arise from here, my dear learners? We can actually ask you and give you perhaps the reactants and put an arrow altogether and ask you, to which homologous series does the product of this reaction belong? Now, you will not be able to then give me the homologous series to which the product belongs if you do not know the product. So what does this tell me? It tells me that I need, you know, as a learner, you need to do your rough work on your paper somewhere and indicate it clearly as rough work, where you actually try and determine the product. And when you have the product, only then can you tell me to which homologous series does that product belong. In other words, my dear learners, you cannot do organic reactions without doing the groundwork. Secondly, I could have asked you, to which homologous series does, rather, what is the general formula of the product that is formed in this reaction? Now, I'm looking for the general formula of the product. There is no way that you can determine the general formula of this product when you don't know the product. So firstly, you do your rough work, you determine the product, and then you see that the product belongs to the homologous series haloalkanes. So when it belongs to the homologous series haloalkanes, you can then tell me that, oh, the general formula of haloalkanes is CnH 2n plus 1 2n plus 1 x, right? Where x is any, where your x can be any halogen altogether, where your X can be a halogen. For example, it could be fluorine, right? F. It could be chlorine, which is Cl. It could be Br, which is bromine. It could be I, which represents iodine. Now, what you should note, my dear learners, is that for your syllabus anyway, we only stick to chlorine and bromine. Then you would have been able to determine the general formula, but you can only determine the general formula provided you know to which homologous series does the product belong. And for you to know the general, rather the homologous series to which the product belongs, then you need to draw for yourself on the side the actual product. So this type of reaction, we call it substitution. And remember, normally what we do is our reaction conditions, if they asked us to write a fully balanced chemical equation, our reaction conditions, which is heat, we will write it there on the arrow. It doesn't matter if it goes up or if it goes down the underneath the arrow. And then underneath here, you will then represent your high pressure altogether. That is going to be your high pressure. So you will indicate it there altogether. And lastly, my dear learners, remember, after writing down a balanced chemical equation, just double check for yourself that the number of carbons on the left is equal to the number of carbons on the right. And then you check the number of hydrogens on the left must also be equal to the number of hydrogens on the right, and the number of chlorine atoms on the left must be equal to the number of chlorine atoms on the right. And when you have done that, my dear learners, you know that your balanced chemical equation is correct. And I'll give you a tip for every organic reaction. This is what you must remember. Use the code RCP. It means you must have your reactants on the left-hand side of the arrow. You must have your conditions on top and just beneath the arrow. And then you must have your product on the right-hand side. So always remember, if you always recall this code, then you will not forget to put your conditions. Are we together? Right. Then we move to alkenes. So for alkanes, what we have done so far, it's simply combustion of those alkanes as well as substitution. So now we are going to look at another homologous series, and that is alkenes. Now with alkenes, we are only going to look at one type of reaction, and that type of reaction is called addition. Now, my dear learners, just as a recipe for you and for your syllabus, when you see an alkene reacting, and I ask you for the type of reaction, for as long as the alkene is the reactant, then you must know the type of reaction is always going to be addition. Now, what happens during addition? For example, let us look at this molecule. Now, my dear learners, you will recall that this molecule is propene or prop1-ene. Now, this double bond there, it's a bit unstable when this prop1-ene is reacting with another molecule. And because it becomes unstable, then the double bond there can be broken. And when you break that double bond, it means you are making this carbon to be short of one bond. So basically it will have 3 bonds. And again, you are making the second carbon to actually be short of a bond. And because the double bond breaks, it means you can actually add a molecule there, rather an atom there, and you can add an atom on that carbon, provided this double bond is broken. So let us say we take prop 1 in and we react it with Br2. So 2 bromine atoms that are bonded to each other. So it's a molecule of bromine. So what we can actually do is we can break that double bond there. Can you see when we start, we had a double bond there between carbon 1 and 2. And now we break the double bond between carbon 1 and 2. And after breaking the double bond between carbon 1 and 2, then I can then add 1 bromine atom there, and I can add 1 bromine atom there altogether. And the rest of the molecule remains as it was. So what I have done there is that I had a double bond, and now I have broken the double bond. The fact that the double bond has been broken means that the type of reaction is addition. Again, what tells you that you have definitely done addition? Remember, there was no bromine atom there. There was no bromine atom on that other carbon. But now there is a bromine atom and there is a bromine atom. So you have added those bromine atoms. This 1, 2, 3, 4, 5, 6 hydrogens were there. 1, 2, 3, 4, 5, 6. So what we can definitely see is that we have added the bromine atoms. And for us to be able to add those bromine atoms, we break the double bond. So the type of reaction there is then addition altogether. And you can see the double bond when it breaks, that is the only carbons where you can actually add your bromine. So when we look at this carbon to that carbon, we can see that this carbon is not affected by the double bond. And as a result, there is no bromine that I can add there. The bromine atoms are added where the double bond is broken. Are we together? Then what did I say to you? I said we are going to deal with RCP. In other words, when we write a fully balanced chemical equation for organic reactions, we will give reactants 1, done, we get a mark, and we most probably going to get a mark there. Then our products, we will definitely get a mark, and if everything is correct, most probably we can get 2 marks. Then we are left with C, which are the conditions. So for this molecule, we require an inert solvent, right? Also an inert solvent, we also call it an unreactive solvent, because if a chemical is inert, it means that it does not react. It is not reactive, so it is unreactive. So you could write there inert solvent, or you could write on your arrow unreactive solvent. Why? Because I told you that our conditions will write them either just on top of the arrow or beneath the arrow. So those are the conditions that must be met. And we can see that our product belongs to the homologous series haloalkanes. And what I also said to you, my dear learners, is you need to make sure that you check that the number of carbons on the left is equal to the number of carbons on the right. So I can see I had 1, 2, 3 carbons. On the right, I have 1, 2, 3 carbons. On the left, I have 1, 2, 3, 4, 5, 6 hydrogens. On the right, I have 1, 2, 3, 4, 5, 6 hydrogens. On the left, I had 2 bromine atoms. On the right, I have 2 bromine atoms. So I'm also going to get a mark for balancing altogether. So this is a fully balanced chemical equation. Now, what you should also see there is that what we have done is we have taken the bromine atoms and we have added them to that molecule. And because bromine atoms are halogens, then we can tell them the type of addition that we have made, what we have added, and the type of addition, because the bromine atoms that we added, those ones are halogens. So the type of addition is then called halogenation. So you must be able to differentiate again between the type of reaction as well as the type of addition. Altogether, the type of reaction is addition because you had a double bond, the double bond was broken. You didn't have bromine atoms, now you have added the bromine atoms. So the type of reaction is addition. When we say the type of addition, we are basically asking you, what have you added? So we have added halogens. So the type of addition is definitely halogenation, and it's not halogenating, it's halogenation altogether because it's an addition, it's a process that is taking place. So we'll look at one last addition for today, and that will wrap up our lesson, and we will continue with more of those tomorrow. Right, let us look at another type of addition. Now, here I did not indicate the type of reaction because I want you to be able to figure it out. Number one, we can see here that an alkene is reacting. And for the mere fact that an alkene is a reactant, right? And it reacts with HBr, we know the type. We know the type of reaction that is going to take place here is going to be addition. Now, how do we figure out that the type of reaction that took place here is addition? We first look at our reactant. We say, okay, in our reactant, it is an alkene, and there I actually have a double bond. But now, in my product, I can see that the double bond has been broken. For the mere fact that the double bond has been broken, I had a double bond, but now the double bond is broken. It means my alkene has undergone addition. Altogether, my dear learners, that's the first thing. What else is telling me that this molecule has undergone addition? Can you see there? This molecule had 1, 2, 3 carbons. Well, it still has 1, 2, 3 carbons. We are fine with that. It had 1, 2, 3, 4, 5, 6 hydrogens. Again, it has 1, 2, 3, 4, 5, 6, but there I have the 7th hydrogen. It means now I added a hydrogen. Furthermore, there I can see that now I added the hydrogen. When I look at this carbon, which was the reactant, and that carbon, which was the product, now there's a hydrogen. Again, when I look at this carbon, I can see there was no bromine, but now I can see this carbon is with a bromine. So I can see that I added a hydrogen and a bromine. And I can see that in the product. So it means I added it there. So that also tells me that I have done addition. So 2 things here are guiding me in terms of addition. The double bond, sorry about that. The double bond was there, but now the double bond has been broken altogether. So that tells me that it is addition. Also, I didn't have a hydrogen there and a Br. Now I have a hydrogen and a Br. So I've definitely added. So I've definitely added there with HBr. Now we know the type of reaction is addition. But what type of addition is this? In other words, I am explaining what I have actually added. And I can see that I added a hydrogen and I added a Br, which is bromine. And I know that bromine is a halogen. In other words, I added a hydrogen and a halogen. I added a hydrogen and a halogen. So the type of addition is then hydro, to show that I added a hydrogen, and halogenation, to show that I added a halogen. So in full, the type of addition is then called hydrohalogenation. And don't take this for granted. Some of the mistakes that we observe, my dear learners, is that a learner will be saying the type of addition there is hydrogenation, halogenation. No, we first say it's hydro, it's cut. Halogenation, and you also can say it's halohydrogenation. So there are quite a number of those mistakes that we observe, my dear learners, altogether. And then remember what I said again, in all our reactions, we are going to remember using this code, and this will help you a great deal. RCP. Remember what RCP means, and I'm sure you know it by now because we've been revising it since the beginning. R is for reactants, so all my reactants are there. I get a mark there. I get a mark there. Then I go to my products. Do I have my product? Yes, there is my product, and this is likely to be 2 marks. Why? Because firstly, we want to see that there is a functional group that is correct, and also the entire molecule is correct. And the entire molecule being correct means that around each carbon I have 4 bonds altogether, and we can see that we actually dealt a lot with that in the previous week altogether. Then another mark that I'm going to get, my dear learners, will be for the conditions. So the conditions there is that I require an inert solvent, or other learners can call it an unreactive solvent. So how do you memorize this as well? Anything that has to do with halogenation, my dear learners, will require an inert solvent. And what did I say to you? We are going to put our conditions on top or just beneath the arrow altogether. And if I just go back to the previous slide, can you see this is also halogenation, and I required an inert solvent. So that tells me, okay, Menier, anything that is has to do with halogenation somehow, I require my reaction conditions as an inert solvent. And you can also see that the product of this reaction, which is this one, belongs to the homologous series haloalkanes. And the last mark, my dear learners, will be also be for balancing altogether, because you would have ensured that the number of carbons on the left is exactly equal to the number of carbons on the right hand side. Then the number of hydrogens on the left hand side must also be equal to the number of hydrogens on the right hand side, and the number of bromine atoms on the left hand side must be equal to the number of bromine atoms on the right hand side altogether. And that is, in a nutshell, hydrohalogenation. That is the type of addition reaction that took place here, but the type of reaction is addition altogether. So we will be continuing more with more of addition reactions, as well as reactions of haloalkanes as we go through the week, as well as polymerization reactions. So be able to deal with these types of reactions, which is your combustion that we dealt with at the beginning, your substitution as well as addition. Tomorrow we'll definitely look at another type of addition, which is hydration, and we'll look at another type of addition, which is hydrogenation. And then we will also look at reactions of haloalkanes as well as polymers. So I really hope that you have enjoyed the lesson. I did, and go and practice altogether. Take a pen, write down the reactions, do your own reactions, take previous question papers, and definitely try to work out this type of reactions, and you will see that you will get used to them and it will become easier. Like I said, we can ask you so many types of questions regarding these particular reactions. And that is why, for those that have actually not written their preparatory examination, you will know that for this particular preparatory examination, organic reactions in organic chemistry are going to be plus minus 29 marks. And why is that? Because for just the preparatory examination, organic chemistry in itself counts 85 marks. So that is very important, and make sure that you really do well in this particular section of the work. Right, and as I always tell you, once you stop learning, you start dying. So go and learn and learn and learn. And as we go throughout the week and you want me maybe to assist you tomorrow, remember what to do. You do the right thing. You send me questions to stemdigitalschool@africateengeeks.co.za, and I will be able to share a question with the rest of the learners, and I will be able to assist you with anything that you ask, and also for Saturday. So thank you very much. I look forward to seeing you. Thank you so much, and enjoy the rest of the evening. Goodbye.